All right, Coach Byerly here, and today we are doing a little exponential regression. Exponential regression is used to model situations in which growth begins slowly and then accelerates rapidly without bound, or where decay begins rapidly and then slows down to get closer and closer to zero. So on the calculator, and we'll show you the steps for those with a calculator, I'll be using a TI-84. Hopefully at home you have one of those. There will be a video added extra that will not be part of this video that shows how to use Desmos on a laptop, and you'll have instructions on that. So if you do not have a TI-84 or a calculator downloaded where you can enter your points and get the graph, then you may want to watch that Desmos video that will be added. Also, today is a short lesson. You will have your review. Next class period will be your test for Unit 11. So let's get this going. And we will start off by reminding you what our information was from a couple of days ago when we were writing exponential equations from a table. So a couple of days ago when we were writing exponential equations from a table, again, our equation that we use is y equals a times b to the power of x. So a again is the y value. It's the value of y at your y-intercept. So when x equals 0. And the b is the pattern of multiplication. So how much it is increasing or decreasing what you would multiply to get from one value of y to the next. All right, so this first example gives us the calculator steps. We are given a set of points, and we are going to write an equation in exponential form, rounding to the nearest hundredths. So 2 places after the decimal. So with your calculator, and again, if you have a calculator maybe downloaded on your phone or your own calculator that may not be a TI-84, or in this case I have a TI-83 Plus, so one of the older ones in the classroom. These are the steps you'll follow. You may have to kind of search for that if you have a different calculator. And again, there will be a video added for how to do this on Desmos if you have a laptop. So first of all, we will hit the Stat button. Okay, so on your calculator, Stat button, and it is already highlighted on Edit, so we hit Enter. And let me delete my previous entry points. So under L1, we are going to put our X values. So I will enter 0, 1, 2, and 3. And then go over to the Y values in L2 and put in 6, 17, 56, and 158. Okay, once I've entered my X and Y values in L1 and in L2, I'm going to again hit the Stat button. Now I will arrow over to Calculate. So up top, I'm not sure if you can see that with the reflection, probably not, but I will go over till it says it's highlighted on Calculate up top. Just arrow once to the right will get you there. Now, if you press 0, that is for exponential regression. And again, if you go all the way down and arrow down past 9, that gets to 0, which is, again, exponential regression. Now, on the newer calculators, the yellow, I think the TI-84 Pluses, you need to hit Enter 5 times, and it goes through different options to get there. But I believe on this one, I just have to hit Enter twice, and this calculator shows this. It's going to show that same thing, y times a b to the x power, and it gives me a equals 5.915. So I'm going to round the 1 up to a 2 because 915 would round up to 92, and my b value is 3.0 0.005. And again, since that third number is 5, I'm going to round this 0 up to a 1. Okay, so I have my A value and I have my B value. Now all I need to do is put that, see if one of these markers will work, change the color scheme, put this back into this equation right here. So we have y equals, my A is 5.92. Hope I don't run out of room on the board. I think you can still see that. My B value is 3.01. Putting that in parentheses, and our exponent is x. So that would be the equation for exponential regression given this set of points. All right, next example. It says write an equation in exponential form from the given data. State whether it is growth or decay. All right, so as we look through this, okay, as the time increases from 0 minutes to 2 to 4 to 6 to 8 and so forth, notice that our temperature is going down. Okay, so this will be decay. All right, and again, let's look at our values on this. So my first objective is to enter this in the calculator. Same steps we did before. So I'll press stat. And again, this set of notes, you should have hopefully the copies of this. I know in my class we had, I think on day 1, you should be able to click that link, and hopefully you've been following along the previous days. So as I go to stat, hit enter, it's already on edit. Enter my x values under my L1. Once I've done that, I go to L2 to enter my y values. Again, make sure they match up across from each other. Make sure you type those in correctly. Again, one incorrect number will mess up your problem here. So mess up your solution. So once I've done that, I'm going to stat, arrow to the right to calculate, and press 0. Which again, if you have a calculator that is different than a Texas Instrument, whether it's TI-83 or TI-84, you may need to pick a number different than 0, or you may have to upgrade your calculator. I know some of the calculator apps require an upgrade to do this. And again, this will be on Desmos if you need to go that route. So once I've hit calculate, I go to 0, and when I hit enter twice on this calculator, it gives me the value of A is 180.376. So 376 will round up to 38. Okay, the value of B is 0.953. So that 5 will remain the same. And again, since this value of B in this case is less than 1, so anytime our value of B is less than 1, then we have decay. In my equation, again, we're writing in this form. So y equals A, I don't know if you can see that or not, hopefully, times B to the power of x. So my equation is y equals, A is 180.38, parentheses B is 0.95. So we're multiplying 0.95 times the 180.38, and my exponent is always x on these problems. Okay, so this now says, below this, hopefully we can see this on the screen, it says use the equation to predict the temperature of the soup after 20 minutes, and then round to the nearest tenth. So again, x in this problem is time in minutes. Okay, so if we continue and get 12 minutes, 14, 16, so forth, again, the temperature is going down. So at 20 minutes, it should be well below the 110. So let's plug in 20 for the value of x. So y equals 180.38 times 0.95 to the 20th power. And I did that earlier, but let me double check this. So 180. Now, when you do this, we don't need the y equals. You're just doing a calculation. So don't go to y equals like you would if you were graphing right now. So 180.38 times 0.95 raised to the 20th power, 64.663 degrees. And this says round to the nearest tenth, which would be one decimal place. So we will go with 64.66 would round up to 7 degrees. All right, problem 3. Jean invested $380 in stocks. Over the next 5 years, the value of her investment grew as shown in the table below. So she began with 380. Each year it grew, it got bigger and bigger. So obviously this is going to be growth. Again, our value of b should be greater than 1 when we work this out. Okay, if we are putting this in a calculator again, stat, edit, so we hit enter, it's already on edit. We enter our x values for the years in L1. L2 will be the stock value. Okay, so I've got that entered. If you need to pause right now, you may do that. All right, once I've entered my points, then again, stat, arrow to the right one time to calculate, and press 0, or on your calculator, whatever that would be, to get the exponential regression, which again should look like this on most calculators, okay, abbreviated. All right, and once I've done that, my calculator shows me A is 379, and I'm guessing we'll still go to the nearest hundredths right here. So 379.919, which would round that up to 92. The value of B is 1.039, so that would round up to a 4. In my equation, y equals A which is 379.92 times B, 1.04 to the power of x. Okay, now if we are using this equation to predict the value of the stock after 10 years, what it will be in 10 years, after she purchased it, we are just plugging, again, the number of years is our value of x. So our exponent, we're plugging that 10 in for that x. So if I go y equals 379.92 times 1.04 to the 10th power, let's see what that gives me. So, and again, in the calculator, you don't need to go to y equals. That's my equation, but don't get confused trying to put that in like you would if you're graphing. So 379.92 times 1.04 raised to the 10th power gives me 562, and we're going to the nearest hundredth. Again, dealing with money, that makes sense. So we want to go to hundredths for our cents, and that would be 562. And 374 would round, it would say the same, so 0.37. So that would be $562.37. It's what she would have as her investment grew for 10 years. All right, problem 3, last problem, says the table shows the value in dollars of a car over time. Find the exponential model for the data in the table. So again, our x values, we will enter into L1. The value in dollars will be the y values, which will go in L2. So again, we'll do this fairly rapidly. If you need to pause to enter your points, do that. So stat, it's already on edit on my calculator, so I hit enter. Again, L1 would be the age of the car. Those are our x values. L2, again, should match up. They should, again, double check your numbers. It's very easy to accidentally hit an extra key or a wrong key, and one incorrect number will mess up your equation. So once I've entered all of those, stat, arrow to the right to calculate, and then number 0 on the Texas Instrument calculators is, again, exponential regression. So on this one, I have to hit that twice. On the newer calculators, it would be 5 times. And that gives me the value of A would be 15,600.550, which would remain 0.55. Value of B is 0.865. So that, let's go to the hundreds again. That 5 after the 6 would round that up to a 7. So 865 would round up to 0.87. Now again, since this number, the B value is less than 1, it shows decay. And again, that's easy to see here. The value of our car started at 15,600. Each year it was valued less than the year before. So again, that would be decay. My equation is A times B to the power of x. So 15,600.55 times 0.87 to the power of x. Now, if we're looking at the value of the car in 8 years, again, number of years is our age of the car, so we're going to plug that in for our x exponent, our exponent of x. So if I go 15,600.55 times 0.87, and then raise that to the power of 8, that 15,600, see what that gives me. That's 0.55 times 0.87 raised to the 8th power is $5,120.28. So again, that car is not worth near as much as when you got it, but if it lasted for 8 years for you, hopefully it was worth it. So again, exponential regression today. Don't forget you also should have your review for Unit 11 tests. And any questions that you may have, make sure you get back with your teacher through email or however you usually communicate with your teacher.